welcome back. Today we join a craftsman seeking refuge high above the forest floor, using only what the jungle provides. She begins by clearing deadwood from the upper canopy. Removing these brittle limbs prevents accidental falls during construction and opens a clear line of sight through the dense foliage. Harvesting structural timber on a steep incline requires careful footing and precise blade work. Green wood is chosen for the primary supports. Its high moisture content allows it to bear heavy dynamic loads without snapping. Hours later, the raw timber is brought into the canopy. She lashes the foundation poles using flexible forest vines. Green vines lock tightly as they dry, shrinking around the wood to create a bond as rigid as modern fasteners. A suspended platform must distribute weight evenly across the host tree's living branches to avoid damaging the cambium layer. By cross-hatching the joists, the floor gains immense shear strength. This creates a level, stable base, high above the damp, uneven ground. Broadleaf palm provide an immediate waterproof barrier. The structural integrity of a thatched roof relies entirely on overlapping layers, starting from the eaves and working upward. This natural shingling effect guides rainwater down and away from the living space, preventing pooling. She binds the fronds tightly to the rafters. Wind is the greatest threat to a canopy shelter, so every leaf must be anchored to withstand sudden updrafts. the first phase is complete. The resulting structure provides critical separation from ground-dwelling predators and creeping dampness. High in the branches, the air flows freely. Caloric intake is vital during heavy physical labor. Rendering animal fat in a heated pan provides long-lasting energy, while a small contained fire minimizes smoke output to avoid drawing unwanted attention in the dense forest. Back on the ground, the exposed root mass of a fallen giant offers a natural windbreak. She clears away the loose topsoil to expose the dense, compacted earth beneath. Digging near massive root structures requires caution, as shifting soil can destabilize the deadwood above. Clearing the immediate footprint provides a flat working surface. After clearing the site, she turns to bamboo. Bamboo's hollow, compartmentalized structure gives it an incredible strength-to-weight ratio. Driving the vertical posts deep into the undisturbed soil anchors the upcoming framework against lateral movement. Green bamboo can be bent into dramatic arches without snapping, a mechanical property derived from its parallel wood fibers. By shaping the frame under tension, the seat gains a natural springiness. The horizontal slats are spaced to allow air circulation, preventing moisture buildup in the humid environment. Binding the joints tightly ensures the entire matrix moves as one solid unit under a load. The final piece transforms the root base into a permanent resting area. Comfort is an overlooked element of survival. Constructing on a steep gradient introduces the risk of landslides. To create a level footprint, she excavates a deep trench directly into the hill. This cut-and-fill method redirects surface runoff and provides a secure shelf for a retaining wall. The soil here is heavily saturated. Without a sturdy barrier, the embankment would eventually collapse into the clearing. She selects thick, dense timber to serve as the barrier wall, cutting each piece to ensure a flush fit. Placing the logs vertically against the cut bank takes advantage of their end grain compression strength. When packed tightly side by side, they form a continuous shield that absorbs the outward pressure of the soil. A slight backward tilt increases the wall's load-bearing capacity. Capping the vertical logs with horizontal timber locks the entire barricade together. This distributes downward forces and creates a solid, usable terrace on an otherwise impassable slope. Wooden pegs, carved on site, act as a fastener that will expand and contract at the same rate as the surrounding wood. Steel nails can rust and loosen, but a friction-fit wooden joint only tightens as the timber cures. Laying a floor of thin, straight branches isolates the living space from the damp earth below. The raised decking acts as a thermal break. Before framing can begin, the ground must be swept entirely clean of organic debris, preventing mold and rot from attacking the foundation. Sinking vertical support posts directly into the earth provides immense structural rigidity. A post hole digger removes a core of dirt without disturbing the compacted soil around it, ensuring the walls of the hole remain solid. Once the post is dropped in, she tamps the surrounding earth back into a dense mass. This friction locks the timber in place, turning the ground itself into the primary stabilizing force. The frame now has a root system of its own. Lifting the heavy horizontal ridge beams into place requires careful balance. These top plates carry the entire weight of the roof structure down through the vertical posts. Every joint is locked tight. The triangular geometry of a pitched roof is highly resistant to compressive forces, deflecting gravity outward rather than allowing the center to sag. A rigid skeleton is essential before any roofing material is applied. The steep pitch of the A-frame is designed to shed heavy tropical rainfall instantly. Palm thatch, layered densely from the bottom edge upwards, creates a remarkably effective weather seal. Inside, the space is dark, insulated, and protected from the elements. Protein and fat are crucial for muscle recovery. A slow, steady radiant heat renders the meat perfectly without charring the exterior. The weather shifts rapidly in dense woodland. As fog rolls in, humidities, spikes, and temperatures drop, making a reliable, quick-deploying shelter the immediate priority. She processes a fallen log to harvest straight ridge poles. The wood must be structurally sound, free of rot or termite damage. A tripod frame is one of the most stable freestanding structures in bushcraft. By tying two forward poles together and supporting them with a long ridge pole, she creates a self-supporting skeleton that requires no deep ground anchoring. Draping a synthetic tarp over the spine instantly provides a waterproof canopy. The tension across the fabric sheds water and prevents the wind from catching loose edges. An elevated wooden floor is then laid beneath the tarp, raising the sleeping area above the wet, mist-covered ground. This rapid assembly is a calculated response to the changing climate. Later, she moves to a subterranean design. Digging a deep trench reduces the shelter's profile and utilizes the Earth's natural thermal mass to regulate interior temperatures. A sturdy ridgepole is dragged into place across the excavation. The curvature of the chosen branch is intentional. An arched roof sheds debris better than a flat one and offers more internal headspace. By notching the timber, the frame locks securely onto the trench walls. Leaning secondary branches against the spine forms a low, angled roofline. This tightly packed wood layer deflects wind and creates a supportive grid for the final camouflage covering. The low profile makes it nearly invisible in the underbrush. Operating a fire inside a confined earth shelter carries the risk of smoke inhalation. By establishing the pit directly beneath a ventilation hole, the rising heat creates a draft that pulls smoke up and out. The earthen walls reflect the thermal energy back into the small living space, turning the trench into an incredibly efficient oven. It is an ideal microclimate. The final build targets a location suspended over moving water. A flowing river guarantees a steady resource, but the surrounding banks are prone to flash flooding. Building high in a leaning trunk mitigates that risk entirely. She scales the heavy timber to clear away parasitic vines and loose bark. Bark sheds naturally over time if a platform is anchored to the outer layer rather than the solid heartwood. The entire structure will eventually slip. She processes fresh lumber on the riverbank, preparing for a demanding aerial assembly. Driving wooden pegs directly into the living wood provides a permanent anchor point without introducing rust or metal fatigue. Navigating long poles up into the canopy requires immense core stability and careful leverage. The horizontal joists are secured to the natural forks in the branches, utilizing the tree's own structural geometry to support the floor. She lays a dense deck of thick branches, interlocking them to eliminate weak spots. This suspended floor must hold her weight, the coming roof, and the dynamic stress of the wind. Bamboo returns as the material of choice for the upper canopy. Its lightweight nature is critical here. A heavy hardwood roof would make the entire tree top heavy and vulnerable to snapping in a storm. She lashes the tall poles into an A-frame apex, establishing the steepest possible pitch to quickly shed rain. Horizontal crossbeams are tied in to prevent the triangular skeleton from twisting or bowing under lateral pressure. The framing creates a rigid cage high above the rocks. Forest ferns offer an excellent alternative to broadleaf palms. Transporting them into the canopy is exhausting work, but their dense, feathery structure traps air, providing a high degree of natural insulation. She weaves the stems tightly through the bamboo crossbeams. As the ferns overlap, they form a shaggy, water-resistant pelt that blends seamlessly into the surrounding canopy. This living camouflage hides the shelter completely from above and below. The elevated hut is now a fully functioning refuge. The dense walls block the wind, while the open front allows observation of the river. Structure, landscape, and daily routine operate as one system. From the damp forest floor to the high branches, the environment has been reshaped by hand. Survival is more than endurance, it is foresight.